An orbital is like the world's worst contour map. So what is an orbital? I mean, sure, we all know what an orbital is, but what is an orbital? Have you ever really thought about that? What is an orbital? Let's start by talking about some things that orbitals are not. So you may or may not be aware of this. Orbitals are not ellipses around a nucleus, a defined orbit for an electron around a nucleus. This is not an accurate picture. Do you know this by now? This is also not an accurate picture. It is not concentric circles around an atom around which the electron orbits. This is also not an accurate representation of an orbital. It's not a physical balloon. It's not a physical boundary holding the electron in place. So what is an orbital? This is really more of an accurate representation of what an orbital is. An orbital has something to do with electrons. It's not a boundary, it's not a balloon, it's not a physical space. So what is an orbital? Okay, let's talk about this. Let's start with maybe the simplest atom, the hydrogen atom. I have a separate video about subatomic particles. I'll link to that below. But if you look at just a hydrogen atom, a simple hydrogen atom has one proton in its nucleus. That's what it means to be a hydrogen atom. And it has one electron orbiting that nucleus. And it has 0 neutrons for a standard hydrogen atom. To talk about what an orbital is, then, we need to first talk a little bit about Heisenberg's uncertainty principle. If you're familiar with Heisenberg's uncertainty principle, Heisenberg's uncertainty principle says that there are 2 properties of something like an electron: its position and its momentum, its speed and direction. We can either accurately measure its position, or we can accurately measure its momentum. But the more accurately we measure one property, the more uncertainty there is in another property. So we can theoretically figure out exactly where an electron is, but not really know its momentum, its speed or direction. So we could run a thought experiment. We don't actually do this, but we could run a thought experiment. If we take a hydrogen at nucleus, its proton, and we were to accurately measure the position of that electron. Again, we don't actually do this, but if we did, we could run this experiment and the electron would be here. Then we could run the experiment again and the electron would be here and here. And then we run the experiment lots of times and we get lots of positions for all these electrons. Where is the electron? We're measuring its position. It's in all these different places. So this is what we would eventually get, a picture that looks kind of like this. And we can take this picture and we can more or less draw a sphere around most of these points, around most of these electrons. This is getting us close to what an orbital is. What we've defined here is a sphere, a region of space enclosed by a sphere, where the electron is found most of the time. Sometimes it's not in that sphere, but most of the time it's in that sphere. So we could write an equation for this. There are math equations that define spheres, so we could write an equation to define this volume of space. This is what an orbital is. An orbital is the answer to a really complicated math equation. You'll learn all about it in physical chemistry. But this is what an orbital is. An orbital is an answer to a math equation, a really complicated math equation. What does that math equation tell us? That math equation tells us the probability. It is a probability equation. It tells us the probability of finding an electron. It tells us the probability of finding an electron within this volume defined by this equation. So how do we think about orbitals? We can almost think about orbitals like this. Do you remember this from, I don't know, middle school geometry class or something? This is a contour map. Contour map is some island. It's a random island. I drew this myself, but it looks like it's got 2 little mountains, some kind of, I don't know, little waterfall or something there. This is a contour map of the various elevations of this island, and an orbital is like the world's worst contour map. Why is it the world's worst contour map? Because it only has one contour. I mean, we could draw other contours, right? We could draw contours closer to the center. We could draw contours further out, but we only draw one contour. So a orbital is a contour around a nucleus that defines the probability of finding an electron within that volume. By convention, we call this the 90-95% probability contour. Within this volume, there's a 90-95% chance of finding that electron at any given time. So this is what an orbital is. It's not a balloon, it's not an ellipse, it's not an actual orbit, but it's an answer to a very complicated calculus equation that tells us the probability of finding an electron within that volume of space. By convention, we define that probability to be 90-95%. In that volume of space, there's a 90-95% probability of finding the electron. So here's a question for you. Does the probability of finding the electron get bigger or smaller as these contours get closer to the nucleus? Think about that for a second. Take a moment, see if you can make a guess as to whether the probability gets bigger or smaller as the contours get closer to the nucleus. You might have been inclined to say that as you get closer to the nucleus, there should be a greater and greater probability of finding the electron. But that's actually not true. If you think about it for a second, where is the electron at any given time? in theory, the electron could be anywhere in the known universe around this nucleus, and that is technically true. The 100% probability contour is technically the known universe. The electron for a hydrogen atom could be technically anywhere in the known universe. It's probably not. So the biggest contour, the 100% probability contour, is the known universe, and those contours get closer and closer to zero as you get closer to the nucleus. That should make a little bit of sense. Within this contour closest to the nucleus, you actually don't find the electron very often. It's more likely out here in this area, in this volume. So the 90% contour is the one that we draw, and the 100% contour is the known universe. The probability of finding the electron gets smaller as we define a smaller and smaller volume of space closer to the nucleus. So that's what an orbital is. Maybe you never thought about it that way before. Maybe I just blew your mind a little bit. That is an orbital. This is going to have really important implications later on in organic chemistry. So keep this definition of an orbital in mind. Thanks for watching. If you like what you saw today, maybe let your instructor know about these videos, or your friends at other schools. Check out some of these other videos and playlists, see what you like. As always, don't forget to like and subscribe.